Assalamualaikum warahmatullahi wabarakatuh. A very good day. So for part number 3, we will discuss about the few devices that used to measure the pressure. Okay. So the first device we call manometer. So we learn about manometer first, and then we discuss about the barometer. So both device will use to measure pressure in thermodynamics. Okay, now we look at a manometer. So a manometer actually is a device used to measure small and also moderate pressure difference. Okay, for example, let's say you want to measure gas pressure in a tank using a basic manometer. Okay, for example, the schematic diagram shows the basic manometer where we have a tank. So inside the tank we have a gas. Okay, so the manometer actually consists of a glass or plastic U tube, and at this point we will have a free surface area or free surface manometer fluid, where on top of that surface we will have atmospheric air. So this tube is open to the atmospheric air. Okay, in terms of fluid of the manometer, there are various types of fluid that can be used depend on the what I call the pressure difference that we want to measure. So we can use mercury, water, alcohol, and also oil. Okay, so we'll use the manometer to measure the gas pressure inside the tank. Okay, so the basic principle that we will use for the calculation of the manometer in order to determine the gas pressure inside the tank. So we will use the same pressure basic principle, where we will consider what I call the variation of pressure with depths. Okay, where we know that when the depths increase, the pressure will be increased, and the relationship that we will use will be delta P equal to P2 minus P1 equal to rho G delta Z. Okay, so we will implement this basic principle in our manometer to determine the pressure of the gas inside the tank. Okay, let's say we choose a point 1. Okay, the surface or the line between the gas and also the manometer fluid. And if we implement the constant pressure for the horizontal plane, so we'll have a point number 2. Okay, where we know that for the same liquid with the same density, pressure at point 1 and also pressure at point 2 will be the same, where P1 will be equal to P2 will also equal to gas pressure, P gas. So the P gas, so in this case we want to know what is the value or the formula that can be used to determine P gas or the gas pressure. Point number 3 is at the surface, at the free surface of the manometer fluid, where because the surface of the manometer fluid at point number 3 is what I call open to the atmospheric air, so the pressure of P3 will be same as the atmospheric pressure, P atm. Okay, based on the pressure principle, we will know that pressure at point number 2 will be greater than pressure at point number 3, and the distance between point number 3 and also point number 2 will be equal to h. So if we implement the basic principle of pressure difference, where P2 minus P1 equal to rho G delta Z, So if we implement this formula and also this principle to our manometer, so we'll get this relationship where P2 minus P3 equal to rho GH. Okay, so rho value or density value depend on the type of manometer fluid. If we use the mercury as our manometer fluid, so the rho will be rho or density for the mercury. If we use water, the value of rho or density will be the density of water, and so on. Okay, so because we know that P2 equal to P gas, so we just replace with P2 is P gas, and also we know that P3 equal to P ATM, so just substitute the what I call the value of P ATM. So now we have new equation where P gas minus P ATM equal to rho GH. So we just rearrange the equation because we want to know the formula for gas pressure equal to P ATM plus rho GH. So this is the final equation that can be used to determine the pressure of the gas in the tank by using manometer. Okay, now let's say in our manometer we use different type of fluid layers. For example, here just to show this simplified schematic diagram where we will use different type of fluid. For example, we will use three type of fluid that stack together. So we have fluid A with rho density A, rho A, fluid B with density B, and fluid C with density C, rho C. Okay. And in terms of what I call the depth difference, for fluid A we will have HA, fluid B will have HB, and fluid C will have HC. Assume that the what I call the upper surface of the fluid A, will be open to the atmospheric air, so the pressure at the free surface will be P ATM. So let's say we state that point number 1 is located at the free surface of fluid A, so P1 will be equal to P ATM. Okay, so the surface, so we have point number 2 between the surface of fluid A and also fluid B. Point number 3 between fluid B and also fluid C, and the last one we will have point 4 at the bottom of fluid C. Okay, so if you implement the basic principle of pressure difference, so for individual fluid we will have for fluid A, in terms of pressure difference, we will have P2 minus P1 equal to rho A GHA. For fluid B, we will have pressure difference where P3 minus P2 equal to rho B GHB. And for fluid C, we will have P4 minus P3 equal to rho C GHC. Okay, so let's say you want to determine the pressure of P4. Okay, the pressure at point 4. So we need to rearrange. We need to substitute all the equation into one specific equation. So we need to substitute all the equation. First equation P2 minus P1, and also the second equation P3 minus P2 into the third equation P4 minus P3 equal to rho C GHC in order to obtain the equation for P4. Okay, after we substitute, we'll get that P4 minus P ATM equal to rho A GHA plus rho B GHB plus rho C GHC. Okay, so rearrange the equation, so we'll get the final equation for the P4 pressure at point number 4. P4 equal to rho A GHA plus rho B GHB plus rho C GHC plus P ATM or atmospheric pressure. Okay, now we look at example for the manometer. So we have example 1.3. A manometer is used to measure the pressure in a tank. The fluid used has a specific gravity of 0.85 and the manometer column height is 55 cm as shown in the figure. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within the tank. Okay, so this is a schematic diagram for the problem. So you need to determine the absolute pressure within the tank. So I will not provide the solution. I want you try to answer the question, try to identify what I call the equation that need to be used to determine the absolute pressure within the tank. Okay, all the data already given in terms of specific gravity 0.85, P ATM, and also the height, the column height, which is h equal to 55 centimeter. Okay, so you need to implement the equation that we have learned before in the slide before. Okay, and try to manipulate whatever data given to get the answer. Okay, so I will let you to answer this question. Okay, now the second example for the manometer, example 1.4. So the water in the tank is pressurized by air, and the pressure is measured by a multi-fluid manometer as shown in the figure. The tank is located on a mountain at an altitude of 1400 meter, where the atmospheric pressure is 85.6 kilopascal. Determine the air pressure in the tank if H1 equal to 0.1 meter, H2 equal to 0.2 meter, and H3 equal to 0.35 meter. Take the densities of water, oil, and mercury to be 1000 kg per meter cubic, 850 kg per meter cubic, and 13,600 kg per meter cubic respectively. Okay, so based on the figures, so you need to implement what I call the equation for pressure difference, and also the equation that involve with multi-layer manometer fluid that we have learned just now. Okay, so I hope you try to answer this question. Try to get the water pressure in the tank. Okay, now we want to look at the barometer. So we want to know what the difference between manometer and also barometer. Okay, for barometer, so the barometer actually a device used to measure atmospheric pressure. A device used to measure atmospheric pressure. So the main function of the barometer is we want to measure the atmospheric pressure. For example, we want to measure atmospheric pressure using basic mercury barometer. So this is the basic what I call setup of barometer. So we have what I call the basin of mercury, and also the what I call the cylinder, the glass cylinder or the plastic cylinder, and we will use mercury as our barometer fluid. Okay, so we will have mercury fluid Hg, and on top of the tube, so we will have mercury vapor. Okay, so because the surface of the free surface of the mercury is open to the atmospheric, so we will have atmospheric pressure will act on the surface of mercury for our barometer. Okay, so we use the same principle of pressure, where we have the pressure difference equal to rho g delta z. Okay, let's say we want to measure the atmospheric pressure, so we need to choose a point in the tube that at the same horizontal plane with the atmospheric pressure, and then we will have what I call point number 1, and we will have column height h. Okay, the distance difference between point number 2 and also point number 1. So we know that because point number 2 is on the same horizontal plane with the atmospheric pressure or the free surface of the mercury, so now P2 will be equal to P ATM, the atmospheric pressure. And for P1, the pressure at state number 1, actually the pressure will take the pressure of mercury vapor. Okay, because the surface attached with the mercury vapor inside the tube. However, the value of atmospheric pressure is far higher or far bigger than the what I call mercury vapor pressure. Okay, so by implementing the basic principle of the pressure, so we'll get in terms of formula of pressure difference between state number 2, point number 2 and also point number 1, P2 minus P1 equal to rho HGGH. Okay, rho Hg, because we will use mercury as the barometer fluid. And then we know that P2 equal to P atm and P1 equal to P mercury vapor pressure equal to rho Hg, density of the mercury multiplied by G and also H. Because the value of P atm far greater than I call the pressure of mercury vapor, so P atm minus P Hg vapor will be more or less equal to P atm, because the value of P Hg vapor compared to P atm very small. Okay, so we can ignore the value of I call the mercury vapor pressure. Okay, so now our formula for the atmospheric pressure by using barometer will be P atm equal to rho Hg multiplied by G, gravitational what I call acceleration, multiplied by the height of the column H. Okay, so these are the concept for the barometer. Okay, now example 1.5, the example for barometer. So the question is, so determine the atmospheric pressure at a location where the barometric reading is 740 millimeter Hg and the gravitational acceleration is 9.81 meter per second square. Assume that temperature of mercury to be 10 degrees Celsius, at which its density is 13,570 kg per meter cubic. Okay, this is the schematic diagram. So the barometric reading in the question actually refer to the height of the column for the barometer. Okay, so try to answer by using the formula related to the barometer. Okay, we want to know the atmospheric pressure. So simple what I call simple equation that we have learned just now, where the atmospheric pressure will be rho Hg multiplied by G multiplied by the height of the column. So easily we can get the value for the atmospheric pressure.